Now, what we usually see in research papers are tables with numbers. Many numbers, the more the better. And these numbers usually contain some information about about what the data was supposed to look like, or so condensed information about what the data actually looked like. So in this case, in each column there's a mean and a confidence bound around that mean. So PA, in this case, it's physical activity. So this is intention to do physical activity. And so this is a survey and where I personally have done this, I admit. And I also must admit that I did that partly out of spite, because I was really getting frustrated with how little I could understand when I saw this in research papers. We have the mean and some confidence bound, right? And now we should somehow interpret this whole table and look at, hey, I wonder what's a meaningful difference, what's practically meaningful, and so forth. And what you can see very closely here is that you can't really see that very well, if at all. And one of the reasons is that it doesn't contain information apart from the mean and the confidence bound. That's great if the important thing is the mean. We will later in this part of this course, we will talk about why the mean is really necessarily not the most reasonable or important information about the phenomenon that we are studying. So some people wanted to object, and they said that, well, you can of course put distributional information also in tables, and yeah, I did that too, and the number of target audience, in this case social psychologists, who could interpret skewness and kurtosis, for example, just out of their head, or understand the limitations of standard deviations. Yeah, that group of people is pretty close to nobody. So yeah, so it's a nice idea, and you can of course do that, but what I would prefer to do, or at least do as a complementary thing to these condensed tables, that the reasonability of the condensation depends on many things. In this case, whether these are the important things about the data and the distribution of the data. But what I would want to do is actually present the data. And so this is something that's been much discussed, but I just wanted you to introduce. I wanted to introduce you to this idea. So, what do we want to do is we want to show data naked, and it's not always the best solution, but it often really helps clarify things. So you can see here that you have a classic bar graph, and you had some sort of a confidence bound here with the bar. And so this is one potential thing that produced these bar charts. But the data, you have two conditions, and the one is a bit higher than the other. But as well, what could lie behind this data is something like this. So you have an extreme observation over here, but otherwise these are pretty similar. You could also have a case where the data is bimodal. So in both groups, you have two subgroups that are clearly different in some way. And you could also have a situation where this bar is just a completely unequal sample to this one. And any one of these four options, and probably many more, can give rise to this sort of a bar chart. And when we look at the paired measurements, and you can check the aforementioned paper if you want to look into this a bit more. But just briefly, so paired measurement is where you have, for example, you have a group of people who get measured at before an intervention and then also second time after an intervention. So in this case, it could be something like this. So differences between these paired measurements. So these are now the same individual getting repeatedly surveyed or measured in other way. So this is before the intervention, this is after the intervention. So we see that after the intervention, the values are higher. So what are the options? You could see, it could be a case where everyone improved a little bit. So this is the difference between pre and post measurement. The second option, there are some people who improved a little or decreased, but there are a few people who really got a big boost. So it's skewed. So here we have 3 people who experienced this very large boost. And you could also have a bimodal situation where there are 2 groups, and clearly one group goes up and the other group stays the same. But when you're looking at this, when we have quite a few, like a low number of observations, it's easy to see these things with this pedagogical example. But if we have a lot of data, it begins to be a little less clear.